puts it in. Oh, we're here. Hey, 6-9, key concept, page 356 in your book. Mr. Fricke did an excellent job talking the exterior angle theorem, which just basically says, first off, the three angles in a triangle all combine to always equal 180 degrees. That's a magic number with triangles. Second off, we talked about a little bit of remote interior angles. So if we find an exterior angle, remote kind of means out away from the other. So it's the one not touching the exterior angle is kind of the way you can sometimes look at, not sometimes, all the time. Okay? These two add up to equal the exterior angle. So I just answered number one, but let's write it down. How are the interior and exterior angles of a triangle related? Well, the exterior angle is equal to the sum of the two remote, ooh, I love remote,
heck yeah,
interior angles. Boom. Okay? Questions?
No.
Good. Let's move on. Okay? Mr. Fricke, he said we're going to ixnay number 2. It's out. Okay? Now we go to number 3. Let's read it. I think we get to draw a triangle. Brian draws a triangle with interior angles of 32 and 87 and one exterior angle of 93. Draw the triangle. Label all the interior angles and the exterior angle. Okay, so I'm going to draw a triangle. We'll make it look something like this. Remember, this is not drawn to scale. Okay, not drawn to scale. Here's my exterior angle. Okay, it says my one exterior angle, 93 degrees. The two interior angles are 32 and 87. Well, let's think. Let's go with, hey, remember, 32 plus 87 plus some other number equals 180. Because if we have two of the interior angles, we can find a third. So Mr. Fricke was nice enough to give me a handy-dandy little calculator. I'm going to combine these two terms, 32 and 87. 32 plus 87. That is 119 plus some number is equal to 180. You guys have solved enough one-step equations. We need to take 180 minus 119. So 180 minus 119, I could do that in my head, folks, but it comes out to equal 61. So our third angle measurement, we have 32 degrees, we have 87 degrees, and we have 61 degrees. Now, what do we know? We know the two remote interior angles add up to equal the one exterior angle. Well, this is 63. Which two add together to equal, I said 63. Okay? Which two add together to equal 93? Well, I bet you 32 plus 61 equals 93. So those are going to be our two remote. So here's going to go 32 degrees. It doesn't matter which one. This is going to be 61 degrees, which means this angle has to be 87. Well, let's check it. These two should be supplementary. Well, does 87 plus 93 equal 180? Check it.
Check it.
It does. Bingo. Perfect. There's a nice drawing, not to scale, though. Mr. Fricke probably would have done better.
Yep.
All right, here we go. It says, number 4, we got this diagram. Nice diagram. Now it says, assume that A and B are parallel. That's something we've got to know. What are the measures of angle 1 and angle 2? I don't know.
I don't know either.
Well, there's lots of ways we can figure this out. First off, I'm going to look at this and say, well, there's a straight line. Okay? These three have to add together to equal what? If it's a straight line.
A magic number.
180. So, I'll write it over here. Hey, 37.3 plus 79.4 plus this angle 3, which I'm going to put as an x, is equal to 180. Well, solve the equation. 37, handy dandy calculator, 37.3 plus 79.4. These two combined, 116.7. Next step, using inverse operations, isolate the variable, subtract the 116.7 from both sides. Okay, cancels out. All right, 180 minus 116.7. 63.3 degrees. Now, you may ask, why, Mr. Knoll, did you have to, or did you think about that? Well, remember, they told us A and B are parallel. So there is some type of relationship between 3 and 1. You see it?
Yeah.
That's right. Those are alternate interior angles. So those two angles are congruent. So angle 1 is equal to 63.3 degrees. All right. Well, I'm going to label that in here, 63.3. Now, what do you see? I see that we have two angles of 3 angles inside of a triangle. So, I'm going to take and add those two together, 79.4 plus 63.3, plus, we'll call this angle 2, we'll call it angle Y. Remember, the 3 interior angles have to equal 180. So, once again, combine like terms, 79.4 plus 63.3. This is equal to 142.7. We're almost there. Next step, isolate the variable, get rid of this 142.7. Go to the handy dandy little calculator, 180 minus 142.7. Bingo, 37.3. Oh my goodness, I wonder why it came out to be that way. Hey, I could tell you why. Once again, we could have used our angle relationships that we found earlier, in 6-8. What do you notice about these two angles? That's right, they're also alternate interior angles. So we could have simply just used that relationship, but I didn't want to. I wanted you guys to think about finding another way. All right! What are the measures of angle 3 and 4? Well, that's easy. We already found angle 3. Angle 3, we already found 63.3 degrees. Angle 4, we need to find some relationship. Well, sure looks like angle 4 is on the outside of a triangle. Okay, there it is, on the outside of this triangle here. Now, what do we know? This angle right here, exterior angle, equal to the sum of the two remote interior angles. So once again, we can write a equation to say, hey, these two added together equal this one. Well, that's easy. All we got to do, I'll write it down here, 79.4 plus 63.3 is going to equal angle 4. Add those two together, 79.4 plus 63.3. Boom, 142.7. Questions on that?
I didn't think so.
Nope. Oh, yeah. Sweet. I've been waiting for one like this. Give me some expressions. I love it. I love it. Number 6. Triangle ABC. So I'm going to just draw a triangle, and I'm going to label it A, and a B, and a C. It says angle A, x degrees, angle B, 2x, and angle C is 6x plus 18. What are the measures of each angle? Well, we got to know our relationship with angles in a triangle. The 3 always add together to equal 180, so we can write an equation of those 3 expressions. 2x plus x plus 6x plus 18. Okay, those 3 angles, boom, 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 always will add together to equal
360.
180.
Oh.
There's your line. Do it. You know you love it. Okay? Put the line in there. We got to find the measure of each angle. Well, we first got to find the value of x. So let's combine like terms. Okay? There's a term. There's another term. And there's a third variable term. Add them together. 2 plus 1 plus 6. 9.
9.
Plus the 18 equal to the 180. There is no variable on both sides, so let's get rid of the constant term. So I'm going to subtract 18. That gets rid of it there. I'm left with 9x. Oh my, 180 minus 18 must be about 162.
Nicely done.
Okay? Then we divide by the coefficient. Divide by 9. And
18. Best number in the world.
comes out to equal 18. We
Are
done?
We're done, right? 18 degrees is the measure of the angle?
No.
Oh.
Nope.
Are you sure?
It's the measure of angle A. So remember, the measure of angle A, it was equal to x. Well, x is 18. We're done. There. Boom. 18 degrees. Measure of angle B. Well, if I substitute 18 right in there for x, 2 times 18, 36 degrees.
This guy's good.
Measure of angle C. Well, 2 ways we could find it. We can substitute 18 in there for x, or we could add these two together and subtract that sum from
180.
180. Which way you want to do it? How about we substitute?
Yeah.
6 times 18 plus 18 more. We just got to find the value of that expression. Well, if you listen to Mr. Fricky earlier, he's a multiplying genius. Okay? He took 6 times 10 and then added 6 times 8. Well, 6 times 10 is 60, plus 6 times 8 is 48. That's 108.
108.
Plus 18 more. I can do that in my head. 126 degrees. Okay, there's the key concept. Catch you on the other side on the additional practice. Nice work out there.